So, welcome students. Let's take the eighth example on Pythagoras theorem. In the given figure, perpendicular from A on the side BC. This is a perpendicular from A on the side BC of a triangle ABC intersects BC at D such that DB is equal to this is equal to 3 times of CD. Okay, and we have to prove this. So again, we will apply Pythagoras theorem. We have two triangles in which we can apply Pythagoras theorem. So let's take the triangle ADB, which is the triangle ADB, this triangle ADB. So in triangle ADB, angle D is 90 degree. So AB square is equal to AD square plus BD square. Okay, by Pythagoras theorem. Again, in triangle ADC, this triangle, this smaller triangle, triangle ADC, again applying Pythagoras theorem, we have AC square is equal to AD square plus DC square. In our final, again, we'll apply the same logic. In our final expression, we don't have AD. So let's substitute AD. So let this be equation 1 and equation 2. So from 2, we get AD square is equal to AC square minus DC square. So we'll substitute this value in equation 1. So let's substitute the value of AD in this equation. So AB square is equal to AD, we will write as AC square minus DC square. Then we have plus BD square. Okay, then again, which terms we don't want? We don't want CD and BD. So we are given this relation. So let's substitute this value. So we have CD, we have BC is equal to, from the figure we can say BC is equal to CD plus BD, or BC is equal to BD. BD we can substitute as 3 times CD, so CD plus 3CD, or we have CD, 4CD is equal to BC, or CD is equal to BC by 4. Similarly, we will have BD. BD we can write as, okay, BC is equal to CD plus BD. So now this time let's eliminate CD. So we'll write BC is equal to, CD will substitute as BD by 4 from this equation. BD by 4, BD by 3, okay. So it's BD by 3 plus BD. So again, this is 3 common, this is 4 BD, or we can say BD is equal to 3 by 4 of BC. So this and this. So we'll substitute BD and CD in terms of BC. Okay. Why in terms of BC? Because BC was involved in our final equation. So let's substitute these value of BC and BD. AB square is equal to AC square minus, so instead of CD we will substitute BC by 4 whole square plus BD square. What is BD? BD is equal to this 3 by 4 BC. So it's 3 by 4 BC whole square. So again it's equal to AB square is equal to AC square minus BC square by 16 plus 9 BC square upon 16. So we'll have AC square, this will become 8 BC square. So further simplifying so we'll have AB square minus AC square is equal to BC square by 2, or again we have 2 AB square minus 2 AC square is equal to BC square, or we can write 2AB square, just rearranging the terms, is equal to BC square plus 2AC square. This is the final result which we have to prove. Okay, now let's take the 9th example. In this question says that a triangle ABC with angle B is equal to 90 degree and D is the midpoint of BC. Angle B is 90 degree and D is the midpoint. We have to prove this result. So again we will apply Pythagoras theorem. We have two triangles. So let's take the triangle ABD. This triangle A, B and D. So applying Pythagoras theorem, we have AD square is equal to AB square plus BD square. And then take the second triangle, this bigger triangle ABC, and we'll apply Pythagoras theorem. So let's apply Pythagoras theorem in triangle ABC. We have AC square is equal to again AB square plus BC square. So if we look in the final expression, we have AC and AD and CD. We don't have BD and BC. AD we have, AC we have, we don't have AB, we don't have AB, don't have this, we don't have this. So let's eliminate this first. So we are given the relation that D is the midpoint. So D is the midpoint, so BD is equal to CD. So instead of BD we can write CD. So let's substitute BD with CD square, and BC is equal to 2 times of CD. Yeah, because CD is the midpoint. So let's substitute BC with 2 times CD whole square. Why we are substituting in terms of CD? Because we have CD in our final expression. So let's do this. So we have AD square is equal to AB square plus CD square. This is our equation number 1. And then we have AC square is equal to AB square plus 4CD square. This is the equation number 2. Now we can substitute the value of AB square from equation 1 in equation 2. So let's do this. AC square is equal to AB square. We are going to substitute. What we'll write? AB square is equal to AD square minus CD square. So it's AD square minus CD square plus 4CD square, or AC square is equal to AD square plus 3CD square. Hence proved. Now let's take the 10th example. This question is same as the previous one, only the final expression is changed. Again, we have a triangle ABC and it is right angled at B, and D is the midpoint of BC. We have to prove that AC square is equal to 4AD square minus 3AB square. So again, angle B is 90 degree. We have two right angle triangles. So let's take triangle ABD and apply Pythagoras theorem. So we have AD square is equal to AB square plus BD square. And again, in triangle ABC, we have AC square is equal to AB square plus BC square. This is in triangle ABC. Okay, now again, we have these two equations, equation 1 and equation 2. In our final expression, we don't have BD or BC. So let's eliminate it. Again, BC we can write as BD 2BD whole square. Yeah, so we'll substitute BC as 2BD whole square. So what we will have, AC square is equal to AB square plus 4BD square. Okay, this is the equation number 2 and this is the equation number 1. So as we don't want BD in our final expression, so let's substitute the value of BD from equation 1 in equation number 2. Okay, so again, AC square is equal to AB square plus 4BD square. BD square will write as AD square minus AB square. So we have AC square is equal to AB square plus 4AD square minus 4AB square. Okay, or we have AC square is equal to 4AD square minus 3AB square. This is our final result, hence proved.